ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. I am very happy to share the second video with you all to the second semester mechanical and MTT students. So myself Professor B.R. Umarane, Principal of SJP and Trust Polytechnic Netsoce, will discuss with you some important questions on first unit of a basic electrical engineering. The first chapter, as already I told, electricity and the DC circuits. So yesterday we have discussed some of the questions, and now we'll discuss the second eighth question is distinguish between the conductors and the semiconductors. Friends, as I have told you, electrical engineering materials are of three types: conductors, semiconductor and insulators. Yesterday we have seen, in the last video we have seen the conductors and insulators. Now let us see the difference between conducting materials and the semiconducting materials. So we know that conductors allow the current to flow through them very easily with less opposition or with less resistance, whereas in semiconductors the conducting property of a semiconductor lies between the conductor and the insulators. Okay, so the first difference is conductors allow the flow of current very easily, and semiconductors current flow depends upon the impurity added to it. To the pure semiconductors, if you add some of the impurities, the conductivity of a semiconductor can be increased to a large extent. So this is the unique feature of a semiconducting material. The second difference is the conductivity of a semiconductors is very high, whereas in case of a conductivity of a semiconductor is very moderate. Resistivity of the conductor is very low, whereas the resistivity of a semiconductor is moderate. In case of a conductor, resistance increases with increase in temperature. This property of a conducting material we call it as positive temperature coefficient of resistance. And in case of semiconductor, resistance decreases with decrease in temperature. So this property we call it as negative temperature coefficient of resistance. In case of conductors, the current is caused by the presence of free electrons, and in case of semiconductors, current is caused by the presence of free electrons and holes. Examples of conducting materials are copper, gold, aluminum, etc. And examples of semiconducting materials, silicon, germanium, etc. Now let us discuss the second question number 10 as state Ohm's law and mention its applications. If you see the question paper of previous final exams, so you will find this question has appeared in many of the question papers. So consider this is an important question. So the question is state Ohm's law and mention its limitations. So what the Ohm's law states? The Ohm's law states that the current flowing through a conductor is directly proportional to the potential difference applied between the ends of the conductor, provided temperature and other physical conditions kept constant. Consider that I is the current flowing through a conductor and V is the potential applied across it. Then by Ohm's law, current is directly proportional to V, or voltage is proportional to current. Now we can write V is equal to I into R, where R is a proportionality constant, and this constant is known as resistance of the conducting material, and it is a material property. Now this is about the Ohm's law. Then let us come to a limitations of Ohm's law. What is limitations means where the Ohm's law cannot be applied. It cannot be applied to a complex circuits. It cannot be applied to electrolytes and semiconductors where the current is not directly proportional to the potential applied, and it cannot be applied to a discharge lamps and the vacuum tubes. The fourth limitation is it can be applied only at constant temperature. If the temperature is varied for a given voltage, the current varies. So Ohm's law can be applied only at a constant temperature. Now the next question is question number 12. Determine the equivalent resistance of three resistances R1, R2 and R3 when connected in series across a supply voltage of V volts. Now Ohm's law can be applied only to a one resistance across which an input voltage of V volts is applied. But in practical, it is not possible to say that each circuit will contain only one resistance. So resistances can be connected in series or in parallel. If they are connected in series, how to find out the current, voltage and equivalent resistance, voltage across each resistance and all. Consider resistances are said to be connected in series when current through each of the resistance is same. Applied voltage is equal to the sum of the voltage drop across each resistance. Then the third point is total resistance or the equivalent resistance or the effective resistance is equal to the sum of the individual resistances connected in series. Now consider there are three resistances R1, R2 and R3 connected in series across which a potential of V volts is applied. Now in the figure there are three resistances R1, R2 and R3. They are connected in series. V1, V2 and V3 are the voltages across the individual resistance. Now to this series circuit a potential of V volts is applied. Now by the definition V is equal to V1 plus V2 plus V3 by the definition of series resistance circuit. Now apply Ohm's law to individual circuit. Before that, consider I is the total current delivered by the voltage source and this current I flows through each of the individual resistances. So the total current I delivered by the voltage source is equal to the current flowing through individual resistances. So I can say that the same current flows through each of the resistances and that is equal to the total current. Now we know the current, we know the resistances. Now apply Ohm's law to the individual resistances. Now you can write V1 is equal to, now V1 is equal to I into R1, V2 is equal to I into R2 and V3 is equal to I into R3 because I said the same current flows through each of the resistances. Now substitute equation number 2 in equation number 1. So what you get is V is equal to I into R1 plus I into R2 plus I into R3. You take I as a common, then V is equal to I into R1 plus R2 plus R3. You call this as equation number 3. Now friends, consider that let us say R is the total resistance of the circuit. Total resistance or the effective resistance of the circuit. V is the input voltage applied and R is the total resistance, I is the total current. Then by Ohm's law we can write V is equal to R is equal to V by I. Call this as equation number 4. Substitute equation number 4 in equation 3. Then what you get? V by I is equal to R, so R is equal to R1 plus R2 plus R3 ohm. So R is the effective resistance or the total resistance of the series circuit. If n number of resistances are connected in series, so then we can write, so R is equal to R1 plus R2 plus R3 plus so on up to Rn. So this is the effective resistance or the derivation of finding the total resistance of the resistances connected in series. Okay, now let us come to question number 13. Determine the equivalent resistance of three resistances connected R1, R2 and R3 when connected in parallel across a supply voltage of P volts. Now consider figure. There are three resistances R1, R2 and R3 which are connected end to end. One end of all the resistances are connected to one common point and the other end of all the resistances are connected to another common point across which an input voltage of V volts is applied. Now when the resistances are said to be connected in parallel, it needs to fulfill some of the conditions. So what are those conditions? Voltage across each resistance is same and is equal to the total voltage applied. Now if you see the figure, you can realize there each resistance is connected across, ends are connected across the input voltage terminal. So the voltage across each resistance is equal to the input voltage applied. Now if I is the total current, now this current I divides among the three resistances based on the resistance values. So I can say that the total current is equal to the sum of the current flowing through each resistances. Now as shown in the figure, so the total current I is equal to, we can write I1 plus I2 plus I3. You call this as equation number 1. Now let us apply Ohm's law to individual circuit. Ohm's law to individual circuit. So then what happens? I1 equal to, I can write V by R1. We know that Ohm's law, V is equal to I into R. So I is equal to V by R. So applying Ohm's law to the individual resistances, I1 is equal to V by R1, I2 is equal to V by R2, and I3 is equal to V by R3. So you call this, these are the set of equations number 2. Substituting equation 2 in equation 1. Equation 1. So then we get as I is equal to V by R1 plus V by R2 plus V by R3. Or you take V as a common, then I is equal to V into bracket 1 by R1 plus 1 by R2 plus 1 by R3. Consider this as equation number 2. Now let equation number 3, let R be the total resistance. Then the total current I can write as I is equal to V divided by R. Call this as equation number 4. Now comparing equation 3 and 4, I can write as 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this expression is the effective resistance or the equivalent resistance of the 3 resistors connected in parallel. Okay, so this is the derivation which carries around 5 marks, and you have to practice this derivation. Remember the figures, remember the notations and all, so that derivations, the notations what you take for derivations and the notations what you mention in the circuit diagram, they should match. Okay. Now coming to question number 14, define what is electric power, electric energy, and mention the meters used to measure them. Okay, so the first point is electric power. What do you mean by electric power, friends? The rate of doing the work in an electric circuit is called the electric power. Its unit is watts or the joules per second. Now this power is measured by using a meter called wattmeter. Right? So by the basic definition of electric power, we can write as power is equal to work done per unit time. The rate of doing the work means work done per unit time. If W is the work done during a time interval of t seconds, then P is equal to, we can write P is equal to W divided by T. So again by taking what is work done, work done is equal to V by Q, potential per unit charge. So by substituting all those things, right, so we can write P is equal to V into I. By Ohm's law, V is equal to I into R. If you substitute V is equal to I into R, another equation for power we get is I square into R. Okay, I square into R. It is typed as I2, but you consider it as a I square. Similarly, if you use I is equal to V by R by using Ohm's law, so then the third equation of power we get is P is equal to V square divided by R. It is printed as V2, you consider it as V square divided by R. Okay, now this is electric power. Now what is electrical energy? Okay, the total work done in a given time is called electrical energy. The rate of doing the work is called power, and how much amount of power is consumed with respect to the time, so that is measured in terms of electrical energy. Right, so it is the power consumed in time t seconds. Then W is equal to, energy consumed can be written as W is equal to P into T. The unit of the electrical energy is watt second or it is watt hour. The practical unit of electrical energy is kilowatt hour. That means if 1 kilowatt is equal to 1000 watt. If 1000 watt of power is consumed for a time period of 1 hour, then we can say that 1 unit of energy is consumed. Okay, then the meter used to measure the electrical energy in the electrical network is energy meter. Okay, now let us come to question number 15. Define electric power and write the 3 equations of electrical power with the current, voltage and resistance. As you know, I have explained you in the previous question. The rate of doing the work in an electric circuit is called electric power. Its unit is watts or a joules per second. Watt meter is the meter that is used to measure the power, right? The three equations that are written in terms of voltage, current and resistance, right? It is discussed in the previous question, that P is equal to V into I. V is equal to, if you substitute I into R, then I into R is I square into R. P is equal to V into I. Substitute I is equal to V by R. So you get the equation as V into V divided by R. V into PV is, you get V square, right? So it is typed as V2, but you consider it as it's V square by R. Now let us come to some of the problems defined, right? So what is on series and the parallel circuit? So there are three resistances of 6 ohm, 4 ohm and 10 ohm are connected in series across a supply voltage of 100 volts. Find the effective resistance of the circuit, total current in the circuit, current through each resistance and voltage drop across each resistance. Very simple questions, straightforward, directly substitution in the formula, so you can get the answer. First, when the problem is given, what the students have to do is read the problem once or twice and carefully write down what are the given datas. Okay, so from the given datas, you see there are three resistances. So I consider R1 is the first resistance, 6 ohm, R2 is equal to 4 ohm and R3 is equal to 10 ohm. These three are connected in series. Okay, then across this series circuit, a voltage of 100 volts is applied. Okay, now first point is, he has asked what is the effective resistance. You have to recall, while deriving the series resistance circuit, we have derived the effective resistance or the total resistance of a series circuit. So what is that equation? R is equal to R1 plus R2 plus R3. Three resistances are given. Substitute these values R1, R2, R3. So we get the total resistance or the equivalent resistance. R is equal to 20 ohm. Then the second question he has asked is I is equal to V divided by R. Substitute V is 100 volt, R we have calculated as 20 ohm. Then if you substitute there, so the current we get is 5 amperes. Then the third point he has asked is what is the voltage across each resistance? Now while deriving the series resistance circuit, so we have taken the equations as V1 is equal to I into R1, applying Ohm's law to the individual resistance. I know the current through the resistance, I know the resistance of the resistor, then by multiplying these two, so I get the voltage across it. So similarly, V1 is equal to I into R1, so that is 5 into 6 is equal to 30 volts. Similarly, V2 is equal to I into R2 is equal to 5 into 4 is equal to 20 volts. V3 is equal to I into R3 is equal to 5 into resistance of the third resistor is 10 ohm. So 5 into 10 is 50 volts. So one point you remember friends here, when you add these voltages here, V1, V2 and V3, we get sum of these three voltages should be equal to the input voltage. Now you see, first voltage is 30 plus 20 is 50, 50 plus 50 is equal to 100 volt and the input voltage applied is 100 volt. So the answers are correct. Now let us come to a second question. It's very important question. It is on power and the energy. So the problem is like this. A 100 watt lamp is used for a 6 hours and a 60 watt lamp is used for a 4 hours a day. Find energy consumed per month and cost of the energy if each unit costs rupees 2.7. Now how you have to calculate the energy consumed per day? There is only two lamps are there here. One is of 100 watt lamp and it is glowing for 6 hours. The second lamp is of 60 watt is glowing for it's glowing for 4 hours. So to know the energy consumed here, energy consumed is given by power into time. First bulb power is 100 watt and it is run for 6 hours. Substitute in terms of time in terms of hours only. Okay, so I write the one equation as total energy consumed per day is equal to power of the first bulb into time at which it is on. Then P2 power of the second bulb into the time at which it is run in 1 day. So that is equal to 100 into 6 plus 60 into 4. So this is the total power, 840 watt hour. Watt hour is the total energy consumed per day. Per day. Now he has asked what is energy consumed per month. In 1 month, considering 30 days, you multiply watt hour into 30. So that gives you 25,200 watt hour. Now we need to convert this 25,200 watt hour into kilowatt hour because I have told you 1 kilowatt hour is equal to 1 unit of energy is consumed, and electricity is charged with respect to the number of units. So energy consumed should be converted into from watt hour to a kilowatt hour. So by dividing the expression value by 1000, so we get the value as 25.2 kilowatt hour, or we can say it is a units. Now for 1 watt it is costing 2.7. The total energy consumed per month is 25.2 kilowatt hour. So we get 25.2 into 2.7, we get the answer is rupees 68.04. Now this is the amount we have to pay to the electricity board. Okay. Now the next question is a house consisting of 2 bulbs of 100 watt each, 3 bulbs of 60 watt each, and 1 fluorescent lamp of 40 watt. If they are used for 4 hours a day, find the monthly consumption charges at 2.7 per unit. Now you see, all the electrical appliances connected in a house are made to glow only for a 4 hours, common 4 hours in a day. So this becomes you see here, not common here, they are different I think. Okay, so 100 watt bulb is how many bulbs are there? 100 watt each, 3 bulbs of 60 watt each, and 1 fluorescent lamp of 40 watt. Okay, right. So 2 bulbs of consider this is a 60 watt, 2 bulbs of 60 watt and 3 bulbs of again 60 watt and 1 fluorescent bulb of 40 watt. So first one I have mentioned here is 100 watt, strike out that and you consider it as a 60 watt. So that is the total power consumed per day I can get as 1360 watt hour. Okay, convert this into kilowatt by dividing the watt hour by 1000. So we get 1.36 kilowatt hour. Now energy per month, energy per day into multiply by 30 because considering 30 days in a month on an average. Okay, so we get the total number of units consumed is 40.8. So what is the monthly bill now? Energy number of units per month into cost per unit. Okay, cost per unit. So 40.8 into 2.7, that comes around 110.16 rupees. Okay, now let us come to a question number 1. So otherwise we'll discuss this in the next class, next video. But till that you go through, almost I have discussed around 17 to 18 questions including these problems. So dear friends, once again I am requesting you all to go through all these questions, consider prepare it for your final examinations, and consider this is one of the best opportunity given to you all by nature to study well and get a good results in the forthcoming examinations. Don't be under the impression that examinations will not be conducted, right? So it's a totally a fake news, and whatever may be the the extension of the lockdown and all, right, examinations will be conducted, and based on the exams what you write, based on that only you will get the result. So till then, a good day and study well. Thank you.